Hello everybody, I'm Adam. In this problem, we're going to be finding the set of parametric equations and symmetric equations, if we can, of the line that passes through our 2 points given at coordinates 7, -2, 6, and -3, 0, and 6. And then we're going to find our direction numbers as integers. So let's get started with looking at our parametric equations. So our parametric equations are given as, see here, so we have x equal to x1 plus a times our parameter t, y equal to y1 plus b times our parameter t, and z equal to z1 plus c times our parameter t. So those are our parametric equations, and so what we need to fulfill these is we need x1, y1, and z1, which those are coordinates from a point that's lying on our line. And then we need a, b, and c, which are the components of a direction vector, or a vector that's parallel to the line that we want to find. So what we need, as we just said, is we need a point on the line, so some point with our coordinates x1, y1, say z1. Well, we're trying to find the line through 2 points, so we could really pick either one of these. Let's go ahead and pick just the first point. So we'll take our point P with coordinates x1, y1, z1 as 7, -2, and 6. And then we need a direction vector. So we need a direction vector, call it V, right, with components A, B, and C. So how can we find that? How can we find a vector that's going to be parallel to the line through these 2 points? Well, we can be a little clever here. We can take V as the vector going through these 2 points, or from our point P, which we're calling our first point, to our second point, which let's just call that, for right now, point R. So V we can find as the vector from our 2 points P to R, right, which in component form, we do component-wise subtraction. So R is our terminal point, P is our initial point, -3 minus 7 gives us -10, 0 minus -2 gives us +2, and 6 minus 6 gives us 0. So that's our direction vector with our A, B, and C numbers. And right now, in particular, we can answer part of our question and at least label these. So the A, B's, and C's are our direction numbers. So we have that A is -10, B is 2, and C is 0. Okay, so with these two things, now we can come back over here and fill in our parametric equations. So for x equal to x1 plus a times t, we're going to have x equal to x1, or the first coordinate in our point P, 7 plus a, -10 times t, or x equals 7 minus 10 times t. Now for y, we'll have y equals y1, which is -2, and then plus b times t, where b is +2, so plus 2 times t. And lastly for z, we'll have z equal to z1, which is 6 plus c, which is 0 times t, or z is just equal to 6. So here is our set of parametric equations for the line going through our 2 points. And the last thing we want to do is find the set of symmetric equations. So our symmetric equations, right, which are given as x minus x1 over a equal to y minus y1 over b equal to z minus z1 over c. So we're going to see from this that we're actually not going to be able to find the set of symmetric equations, namely because our value c is equal to 0. So if we start trying to fill this in, we have x minus x1, which x1 is 7, so x minus 7 over a, which is negative 10, which is equal to y minus y1, or minus a negative 2, y plus 2 over b, which is positive 2, and that's equal to z minus z1, or z minus 6, over 0. And since we can't divide by 0, technically we can't find this set of equations, so our symmetric equations, we'll just say, is not going to be possible. So we have our direction numbers, a set of parametric equations, but our symmetric equations were not possible to be found. And there we go. Thank you very much.